Hi everybody, welcome to the Manifold channel. Today we're going to continue our series comparing the performance and ease of use of Manifold System Release 9 to ESRI's ArcMap with Spatial Analyst. We're looking at an ArcMap desktop right here, which is about over $5,000 worth of ESRI software. ArcMap Standard Edition costs $2,750 as of the time this video was shot. And Spatial Analyst is, in addition, an extra $2,500. You need Spatial Analyst for the hydrology tools. We're comparing this to ArcMap because ArcMap is high-quality software, and ArcMap does parallelize some of the geoprocessing tools. So we want to give ESRI the benefit of the doubt and to use ESRI's absolute best effort at this, which is really, frankly, impressively good software. We're using ArcMap instead of ArcGIS Pro because ArcGIS Pro has a tendency to want to contact ArcGIS online, and sometimes that might interfere with performance timings while ArcGIS Pro is connecting to the web. So we don't want that. We're going to make it as fast as possible. We're going to use ArcMap. What we're going to do is we're going to compute upstream watershed areas for each of these points to see what drains into each of these points from the watershed. We're looking at the Lake Wales Ridge region of Florida here. It's 5,300 pixels by 5,300 pixels. That's not a whole lot of data by Manifold standards, but it is enough for ArcMap to spread its wings and to apply some parallel processing. Okay, so what are we comparing it to? We're going to compare it to Manifold. And here's Manifold Release 9 with exactly the same data, exactly the same drawing. And I'm going to give the game away. Manifold Release 9 will do in about less than a second and a half what takes Manifold, a minute and a half or 2 minutes. So let's get right to it and let's go to work. Here in the Contents pane, we go into the Transform toolbox, which is the equivalent of ESRI's geoprocessing toolbox. All these hundreds of point-and-click transforms. There's so many of them, I'm going to enter WA here to reduce it down to just the ones I want. I want this one right here, Watershed Areas Upstream, using the Florida drawing. And to make it go, I'm going to click Add Component. Ready, set, go. It swings into action, and right away, it's done. It took about a second and a half to create this drawing right here. What it did is it computed a flow direction and whatever else is necessary, flow accumulation, computed the watersheds, and then it did a raster to a vector transform. And it did all that in a second and a half, and here's the drawing that it created. We can zoom in and see that for all these areas there are indeed these upstream watershed areas. The central part of Florida is pretty flat, so it's not tremendously impressive drainage going into each of these areas, and some of them are so small there's virtually no drainage at all because Florida is that flat even in the Lake Wales Ridge region. But ArcMap will create exactly the same polygons. So we did all that in Manifold. How long did it take us? Let's look at the log window, and it took us 1.375 seconds. Great. Let's see how long Arc does it. Now, when you do this in Spatial Analyst, it's a multi-step process. I'll start it going right now. You start by computing flow direction. So let's double-click that open. And the surface raster that we want is Florida Grid. And I have to double-click that to select it. And everything else I leave default. I click OK. And I'll let that cook. Arc is now doing its thing. It's giving us messages telling what it's doing. It's distributing this across 9 parallel instances. What we did in Arc is we set the parallel processing environment to 100%. That means ArcMap itself is deciding how many parallel threads it wants to launch. We're running here on a Threadripper, which is a 24-core CPU, and it can run up to 48 threads. Arc decided it's only going to use 9 of those threads instead of all 48. Manifold, by the way, ran on all 48. Be that as it may, Arc's cooking along and it's doing its thing. It's going to take it about 1 minute and 23 seconds to do a flow direction. We need to do that first, and then we can compute the watersheds on the flow direction. Once we compute flow directions, watersheds will be very quick in Arc. It does that quite quick in Spatial Analyst, but we do have to do this intermediate step first. This is fairly typical of Spatial Analyst, where you have to create intermediate data sets to do what you want to do next. Manifold, in contrast, tends to do it all in one go because that lets it optimize all these multiple steps. And the difference is kind of like the difference between, if you're building out an office building and you want to build a wall for an office, do you want to build the wall with the electricity in it all at once, or do you want to build the wall first, tear it apart, and then put in the electricity? You can do it more efficiently if you build the wall with the electrical runs all done at once. Okay, it succeeded. And there it worked 1 minute and 19 seconds. It's a little bit faster than usual, so probably it's taking advantage of whatever Windows has cache from the last time we ran this. So now let's run watersheds. To do that, we go back in here to the Spatial Analyst toolbox and we double-click on watershed. The input flow direction raster is going to be this one that we just created. Okay, got to remember to double-click that. And the direction is going to be a Florida drawing. That's the points we want to use. Click OK, and watersheds go considerably faster in Arc. And it's doing 4 parallel instances, and it's going to complete it in about 10 seconds, something like that. So there it's done. It took it 10.8 seconds. Let's call that 11 seconds. So all in, Arc took a minute and a half to do this, what Manifold did in 1.3 seconds. So that's remarkably fast, remarkably faster for Manifold. And just to show you that we can do this however many times we want, let's get back in here. Oh, I forgot that back here in Arc I have to convert that to polygons. I got to do the raster to polygon conversion. So let's go here to the Arc catalog, and back here we want to do raster to polygon. And what do we want to convert? We want to convert the raster that we just created, which is the watershed flow, and click OK. And it does it very quickly. So here are the rasters that I created. Let's take a look at them. And you can see there's exactly the same areas, polygonal areas that were created in Manifold. When we let's zoom in here to take a look at those. So that's the same thing. The algorithms used are fairly typically similar. It's just that Manifold parallelizes a lot better. Let's see, in fact, how much better Manifold parallelizes by doing this one more time. And I'm going to delete these guys that I created earlier. And so remember how long it took in Arc. Let's redo it again in Manifold. Watershed areas upstream. Just click Add Component, and it's done in just that fast. It's just amazing how fast that works. You can do it however many times you want. It's faster and faster and faster all the time, and it gets it right every time. All right. So why is it that a less than $500 package Manifold is running 60 times faster than ArcGIS Spatial Analyst with this $5,000 worth of ESRI software here that we have sitting in front of us? There's actually 3 reasons. One of them is that only these geoprocessing tools are parallelized, and ArcMap itself is not parallelized. So when ArcMap is running, it's single-threaded. It's actually double-threaded, so it can run both foreground and background applications. But still, that's not enough to keep all those parallel tools fed. Those parallel tools go through that real bottleneck when they get it's kind of like getting on and off a multi-lane highway, but the entry on and off ramp is only one lane. If you got a lot of traffic, that's going to be a big bottleneck and traffic jam at that on and off ramp. And every time Arc has to talk to these parallel tools, it's sending everything through that single thread. That's logjam number 1. Logjam number 2 is that the parallel tools that ESRI's doing aren't particularly parallelized very well. For example, here it's distributing the operation across nine parallel instances. With Manifold, it's going to distribute this operation across all 48 instances. And in fact, let's run it yet one more time so we can see. Ready, set, go. And let's see what happens here in the Task Manager. You can see in the Task Manager, see these little blips right here? It happened so fast, it took it all in a second and a half, that it didn't really even have time to. Windows didn't really have enough time to record it, but you can see Manifold actually went out there and it used all 48 threads, to do this watershed computation. Manifold does it so fast that it's hard sometimes for Windows Performance Manager to capture all that. And that's the second reason why Manifold's a lot faster than ESRI, because, well, there's parallelizing, and ESRI should be ESRI is justifiably proud that they parallelized a bunch of geoprocessing tools. That's good work, and it's a real advance of what was there before. But it's a first-generation parallelization effort, and it doesn't really use the multi-core processors as well as Manifold does, where Manifold can really launch in 48 threads and not get in the way. Manifold itself runs parallel all the time, so there's no single-threaded application bottleneck. This whole application is running as many cores as you have on your computer, and so when it feeds parallel functions, it can do that very efficiently. The final reason why Manifold is faster is that Manifold's reading and writing from a highly parallelized, very parallel-friendly data store, Manifold.map format, which was designed to support parallel operation. ESRI is reading and writing from GDB, which is a distinctively parallel unfriendly format. So combine all those things, and that's why Manifold at less than $500 does in 1.3 seconds what ArcMap, $5,000 worth of ArcMap plus Spatial Analyst takes a minute and a half. And as these things scale up, as you get into even larger and larger data sets, you'll see that what takes Arc hours, Manifold can do in just a minute or so, or even still seconds. Anyway, thanks for watching. I hope you've enjoyed this demonstration. Stay tuned for additional comparisons speed comparisons between Manifold and ArcMap. And thanks for watching. Goodbye from the Manifold channel. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.